Hello friends, welcome to my new data structures and algorithm in Java tutorial series video. Friends, in this tutorial we will discuss how to delete last node in a doubly linked list in Java. So friends, let's suppose we are given a doubly linked list having 3 nodes with data as 1, 10 and 15. So here you see below is the algorithm to delete the last node in a doubly linked list. So friends, the basic idea behind this algorithm is as we want to delete the last node in a doubly linked list, we will use basically this tail pointer to remove the last node in a doubly linked list, because in a doubly linked list head points to the first node and the tail points to the last node, and we want to remove the last node in a doubly linked list. Therefore we'll manipulate and play with this tail pointer to remove the last node from the doubly linked list. So head pointer doesn't play much role in deleting the last node from a doubly linked list. The only case where head pointer comes into picture is when there is only one node in a doubly linked list, because if there is only one node in a doubly linked list, then head and tail both will point to that particular node, and if you want to remove that single node from the doubly linked list, we need to manipulate head pointer as well. So friends, let's see the demonstration of this algorithm. So in the first step we will check whether the list doubly linked list is empty or not. So if doubly linked list is empty, we'll throw an exception saying that there are no more elements left to be removed. So currently doubly linked list has 3 nodes, therefore the list is not empty. So the condition in if block comes out to be false. Now as we want to remove the last node from a doubly linked list, we'll create one temporary node which will be pointing to the tail. So now temp points to a tail because when we remove the last node from a doubly linked list, it will be removed using this temporary node. Moving ahead. So here in the block we'll check whether head is equal to tail or not. So currently head points to the first node and tail points to the third node. Therefore they are not equal. So the condition comes out to be false and the else part will be executed. Now friends, in order to remove this last node from a doubly linked list, we need to remove these 2 pointers, because once we remove this 2 pointer, this node will be freed and it will be removed from the doubly linked list. So first we'll remove this next pointer because this last node is being referred by the second last node. So we need to remove this link. So in order to remove this link, we need to traverse to the second last node and then assign a null value to its next node. So in order to traverse to the second last node, we'll use this tail pointer. We'll first go to its previous by calling tail.previous, and then to its next we'll assign a value of null. So in this line what we are doing, we are assigning a null value to tail.previous.next. So it simply means we are first traversing to the previous and to the next we are assigning the value as null. So it would look something like this. So this link will be removed and then it will point to the null value. Moving ahead. So friends, once we remove the last node of a doubly linked list, we see tail points to that node. So after its removal, tail should point to the second last node, because that second last node upon removal becomes the last node of the doubly linked list. Therefore we need to traverse tail to its second last node. So we'll simply assign tail.previous value to tail. So it would look something like this. Moving ahead. And then we'll simply break this link and we'll assign a null value to it. So we know that temporary node is pointing to this last node and we need to assign a null to its previous. Therefore we'll simply assign a null value to temp previous. So it would look something like this. So in the final step we know that the last node, which is pointed by temporary node, has been removed from doubly linked list. We'll simply return this temporary node. So friends, after removal of this last node, only 2 nodes are left. So head is pointing to the first node and tail is pointing to the last node. Now if you want to again remove the last node from this doubly linked list, we call this algorithm again. We check whether list is empty or not. So list is not empty. And as we want to remove this last node, we'll create one temporary node and we'll assign the value of tail to it. Moving ahead, we will check whether head is equal to tail or not. So head is not equal to tail because head points to first node and tail is pointing to the second node. Therefore the else part will be executed. And in the else part we'll do the same, as we need to remove this link. So we will traverse a node back and we'll assign a null value to its next. So we'll simply do tail.previous.next and assign a null value to it. So tail points to the second node, and when we do tail.previous we are reaching to the first node, and then to its next we are assigning the null value. So it would look something like this. So the link which was referring to this node, we have removed it. Moving ahead, and as we know that this is the last node of the doubly linked list, because once the last node is removed, the tail should point to its previous node because that becomes the last node in a doubly linked list. Therefore we'll simply assign tail.previous to tail. So it would look something like this. So now head and tail both are pointing to the first node. Moving ahead, and we need to break this link, and that link is referred by temps previous. So we'll simply assign null value to temps previous. So it would look something like this. So as we know that this node is freed, therefore we'll simply return this temporary node. So friends, now in doubly linked list only one node is left, where head and tail both are pointing to that particular node. So let's call this algorithm again. So first we will check whether list is empty or not. So list has one node, therefore it's not empty. Then as we know that there is only one node left and we want to delete the last node, therefore this is the only node that needs to be removed. So we'll simply create one temporary node and we'll assign the value of tail to it. Moving ahead. Now here is the case where head is equal to tail because both are pointing to this first node. Therefore in order to remove this node, we need to break these both links, because head is pointing to this node and tail is also pointing to this node, and we need to break this both link so that this node can become free to be removed. So in the if part we'll simply assign a null value to head. So we have removed one link. Moving ahead, and then we'll simply traverse tail to its previous node by assigning tail.previous to tail. So you see tail previous is pointing to null, therefore we are simply assigning a null value to tail. So it would look something like this. So now tail will point to null, and now we'll simply assign a null value to temp previous. So you see temp previous is already pointing to null, therefore we do nothing, and simply in the last step we'll return this temporary node. So you see now head and tail both are pointing to null and there are no nodes left in the list, therefore the list is empty. So if we call this algorithm again, then first I will check whether list is empty or not. So we know that list is empty and there are no nodes left to be removed, therefore we can throw a no such element exception, because there are no nodes left to be removed. So friends, this was the demonstration of the algorithm. Now let's go to Eclipse and see the working code. So friends, in my previous tutorial, I had created one class by name doubly linked list, and we implemented a doubly linked list into that class. So this class has head and a tail node, and it also has a integer variable by name length, which stores the size of the doubly linked list. So if you want to understand the working of doubly linked list, you can watch my previous tutorials. So in this tutorial we will discuss how to delete the last node of your doubly linked list. So first I will create the method as public list node delete last. So this method will remove the last element and will simply return it back. Therefore the return type is of list node. So first we'll provide a if check as if the doubly linked list is empty or not. So if it is empty, then we'll simply throw a exception, say no such element exception. Moving ahead, we'll create a list node by name temp and we'll assign a value of tail to it because we need to remove the last node from the doubly linked list. Therefore we are using this tail pointer to remove that last node. Then we'll provide an if check. If head is equals tail, then we'll simply assign null value to head, because when head is equal to tail there is only one node left in the doubly linked list. So we need to break both the reference head and tail in order to free that node. So we'll simply assign a null value to head, and in the else part we'll do tail dot previous dot next and assign null value to it. Moving ahead, then we'll simply traverse tail to its previous node, because once the last node is removed, now tail will point to the node just before it, and we'll assign null to temp.previous because we need to break that link as well. And finally, as we delete this node, we need to reduce the length of doubly linked list by 1. Therefore we decrement the length by 1, and last we'll simply return the temp. So friends, we saw the algorithm to remove the last node of a doubly linked list. Now let's test its working in main method. So in my previous tutorial we just discussed how to remove the first node of a doubly linked list. So here I will just call delete last. So here if you see, we have inserted 3 nodes by data as 1, 10 and 15, and first we are removing the last node. So if I run the code, you see first it printed 1, 10, 15 and null. So when we call delete last, so it printed 1, 10, 15 and 15 got removed. And if I call this method again and then I run the program, so you see we called delete last 2 times. So in the first time 15 got removed and the second time 10 got removed. And if I call it again, so if I called it again, so 1 was also removed and nothing got printed, because in display forward we have kept in condition that if head is null then simply return, and we know that we inserted 3 nodes and we removed 3 nodes, so list got empty and head pointed to null. Therefore display forward printed nothing. And if I call delete last one more time, then as we know that list is empty and there are no nodes left to be removed. Therefore you see an exception was thrown because there was no node left to be removed. So friends, in this tutorial we discussed how to remove the last node of a doubly linked list. I hope you like this video. Please like, comment, share and subscribe my YouTube channel. Thanks, have a nice day.